Hello and welcome to the course on bare metal embedded programming with Atmega 328 microcontroller. I am Aravinda Verma, your instructor for the course. In today's lesson, we shall learn about the base circuitry used in our development board. I call it base circuitry as it is used in different projects with additional electronic components. Before jumping into the discussion of the circuitry, let's quickly look into the electronic components required for the circuit. We need a 10 kΩ resistor, a 16 MHz crystal oscillator, two 22 picofarad and two 100 nanofarad ceramic capacitors, a button switch, couple pieces of red and black single strand wire, and the microcontroller Atmega 328. The list of the components is provided in the section. The diagram shows the schematics of base circuit, which is an Arduino Uno circuit. Please note, it is not the complete development board, but it contains three important circuit components. The development board is based on Atmega 328 microcontroller. You'll find two variants of the microcontroller, one Atmega 328 and the other Atmega 328P. P stands for pico power and consumes less power than Atmega 328. You can use any of the microcontrollers available as the only difference between the two is the level of power consumption. The base circuit has three parts. 1. The circuit to reset the development board. 2. The circuit using a crystal oscillator for clock signal generation. And 3. Connections to power the microcontroller. Let's look at the reset circuitry, which is used to soft reboot the development board. A logic low pulse must be provided to the pin number 1 to reset the microcontroller, and at other times the reset pin must be pulled high. The duration of the logic low pulse must be greater than that of the clock signal. The reset pin of the microcontroller is connected to 5V through 10 kΩ pull-up resistor, and it is also connected to ground via a button switch. When the switch is in off state, the reset pin is pulled high. The development board is reset by pressing the button switch. In the operation, the reset pin is short-circuited to the ground, providing a pulse of logic low and resetting the microcontroller. We shall use an external crystal oscillator for clock signal generation. The datasheet of Atmega 328 recommends to use 16 MHz crystal oscillator with 22 picofarad capacitors. The pin number 9 and 10 are connected to the crystal oscillator. Two 22 picofarad ceramic capacitors connect the either pins of the crystal oscillator to the ground. The fuse bit of the microcontroller must be configured appropriately to use the external crystal oscillator. We shall see how to program the fuse bits in subsequent lesson. The pins 7, 20 and 21 are connected to 5 volts of the power supply, and the pins 8 and 22 are connected to the ground. The pins 7 and 8 are connected through a decoupling capacitor of 100 nanofarad. Similarly, the pins 20 and 22 are connected through a decoupling capacitor of 100 nanofarad. We shall follow a simple convention while wiring the development board. The VCC is always connected with red wire and the ground with black wire. The black and red wires are never used to connect the data and control lines. This will reduce the chances of wiring mistake while rigging up the development board. Now let's wire all the electronic components and build the first circuit of the course. This is a breadboard used to connect the electronic components to build the development board. The power rail around the board is connected with each other Notice the red wire is used to connect the VCC of the power rail and black for the ground. With this, we come to the end of this lesson. I hope you must have learned something new and enjoyed the lesson. Thank you and have fun learning.